Hey IB environmental students, this is one of your first sets of notes that's flipped, and we're going to start our topic of systems. If you're doing this at home, make sure you pause so you can see everything. You don't need to write everything down because you'll always have access to this flipped PowerPoint in the form of a video or actual PowerPoint somewhere on Blackboard. Alright, let's begin. We're going to define systems because the IB exam wants you to be able to do it in your own words. So here's the formal definition, but you put it in your own words. It's an assemblage of parts and their relationships forming a functioning entirety or whole. What does that really mean? Okay, let's dig deeper. These types of systems we'll be talking about in class could be living, non-living, or even theoretical. Okay, food webs, that's going to be our living things, like ecosystems. Non-living things, government, that's theoretical too. Or environmental value systems, that's totally theoretical, non-living. We're going to do some examples of systems. I'm not going to go through each of these in depth because that'll take forever. So bear with me, you might want to just write down the title of them, not the details. Atmosphere, that's the air. Crazy, right? It's mostly nitrogen. We think about it as oxygen and carbon dioxide, mostly nitrogen. Pretty wild. Hydrosphere, that's our water. Lithosphere, that's the rocks. Alright, we can think about pedosphere, that's not listed here, would be our soil. Very related to all these things, not listed though. And the ecosphere, that's our living and the non-living things and how they interact. And if we kind of combined all these different aspects together, we would get an entirety or whole, or another system. We'll think of that as the biosphere. Great. One of the main crazy ideas we might think about as Earth as a system, thinking about this idea of biosphere, is if Earth was a whole living organism, that hypothesis is called Gaia. So a holistic view is the Earth as a planet-sized organism. You've seen this in popular culture sometimes. The movie Fern Gully, where the fairies are trying to help the Earth against pollution. Whether or not you've seen that movie, it's about the Gaia hypothesis. Maybe you've seen the blue aliens in Avatar and how they interact with the tree. That's Gaia, that all the different creatures on the planet are interconnected to a whole giant organism. We don't talk about that much in class, but it's an interesting way to think about the Earth as a system, and sometimes IB might briefly mention it. What we will mostly focus on today in these notes are the types of systems that exist. There's three major categories. Two of them we talk about a lot more, and here they are. So the first type is open system, and we'll focus on each of these categories looking at is matter and energy being exchanged or not. So in an open system, matter and energy are both being exchanged within the system and to the external surroundings. This is very typical for something that's a living system. Closed systems, matter is not exchanged, but energy is. So I'll repeat that again. Energy is exchanged, like light, but matter is not. There are no natural occurring systems that can sustain themselves for long periods of time that are closed, and we'll get more into that in a while. Lastly, isolated, and you can't see this part at the end, but I'll let you know what it says. No matter or energy is exchanged, and the only example we have is the universe, and that's kind of a complex, almost physics idea. So we're just going to take that at face value for this course, but you do need to know it. The only isolated system out there is the universe. We're going to mostly focus on these upper two, open and closed, and we'll kind of think about it looking at this picture over here to the right. What kind of system is this guy? For all intensive purposes, we're going to pretend that this system is alrighty. So this system here, we have the light maybe penetrating into the fish tank. Maybe it's the light source here, but we could also have sunlight coming in here. So is energy being exchanged with the external surroundings? Oh yeah, it is. What happens if too much light's here? What happens to the water? Well, eventually it'll evaporate, alright? And if it really could evaporate out of the wall, the humans might need to add more water. If we are in fact adding more water, what kind of system is this if matter and energy are being exchanged with the external surroundings? And these fish are able to survive for a very long time, and they are in fact biological. What system is this? Open, right? If matter and energy are both being exchanged, it's open. So we're going to kind of try to do this in graphical ideas. So here's our system. We're going to look at it as a circle, right? Here's another one and another one. Let's try to label them. We can see energy and matter. The bottom one, matter, is being cut off here. But what do you think this first one is? Is energy or matter being exchanged? No, it's not. So that guy's got to be isolated. And the second one, only energy is being exchanged. Can living things live there if only energy is being exchanged? No, that guy's closed. And lastly, that leaves open. Open is the one where biological things are going to be able to survive. We're going to need matter and energy coming into the system, input and output, in order for living things to survive. We'll talk. So, now what I want you to do, now that we've looked at both the definitions written and we looked at some graphical versions, I want you to come up with your own examples of each of these types of systems. If we were doing this at home, I would expect you to come to class next time ready to present to others or myself those examples. So take a moment now. You might need a pause, but think about this. Great. We're going to move on. Now we're going to think about those inputs and outputs and how matter and energy moves between different places in a system. If it's purely just moving, we call that a transfer. For instance, water can move from rivers to oceans. That's just water moving from one place to the other. Nothing's happening to the water other than it's going from two different places. When an organism eats, matter is also going to move from one to the other. So let's say I eat a chicken. The chicken is made of matter. That matter is going to go into my mouth, into my stomach, and be incorporated into me. That's just moving from one organism to another. Oppositely, matter can move but simultaneously change states or forms. Let's do some examples and I think it will make more sense. So let's think about energy. Energy during the process of photosynthesis goes from one form, radiant energy, to another form, chemical energy. The sun's energy through this process will change into a molecule. If you remember from biology, that's glucose. Then that's chemical energy. Changing its state or form, that's called a transformation. Precipitation is going to be the matter water going from one state, gaseous, to a liquid state when it becomes part of rain. Burning coal will produce light. That's going from matter and to energy. This is a pretty crazy process through combustion. We won't hit on that too much during this class. It's a bit more of a chemistry thing, but it is a pretty good example of transform. If you're having trouble remembering this idea, think about the movie Transformers. The cars are really turning into crazy different other forms. So here's our last idea for today's podcast. Equilibrium, the tendency to return to an original state following a disturbance, a state of balance. We got two major types of equilibrium we'll be talking about today, and then we'll compare stable and unstable. So the two types. The first one is steady state or dynamic, considered stable even though it has lots of fluctuations. And here we can see all these fluctuations. Look, bloop, 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 bloop. Pretty crazy, right? Let's compare it to the next one. Static, very little change throughout the period of time. But what's crazy is even though they look different, they're pretty stable. And we can see that easily looking at the average over time. Even though the system has these crazy fluctuations, overall the average is very much the same as the static one. So either way, there is this equilibrium that this one keeps coming back to even with fluctuations, and this one doesn't really come away from equilibrium all that often. These are two different versions of the very same idea. We just kind of categorize the two types separately. We'll practice this more during class. Two other ways to look at equilibrium. We could see some systems are very stable and other systems are unstable. And sometimes systems can change from one to the other. We'll talk about this a lot in the course. So a stable system that no matter what kind of forcings or inputs, the system will kind of push back and forth, but it relatively stay in equilibrium. If you see this, these balls would pretty much fall into this same balanced state. Without this one's a little difficult. No matter which way you push this ball, it's gonna pretty much be indifferent. The state won't change. And when we see this unstable equilibrium, we think about different states of equilibrium as where the ball can end up, there could be very different places this current one could end up, either this side or that side. So human impact on the environment is worse for which types of equilibrium? And we can't really see this bottom, but which one would be worse if humans were impacting it? What kind of system? Yeah, definitely this unstable one. So if a human were impacting this one, we'll pretty much, no matter what, we're going to come back to equilibrium. But if we push, oftentimes we think of our systems a little bit more unstable, and maybe some organisms will be able to live in an unstable equilibrium situation. But if we push out of the stable state we're used to living in, potentially we might go to a different new equilibrium position that humans aren't used to living in. This is a little abstract right now in the course, but we'll get back to this a lot later. So just hold your horses, and that's it for today, guys. Good job.